Good evening, and welcome back to AP Stats Notes Online. Glad to get back into this format a little bit. Want to get into Chapter 1 again. Starts talking about different types of variables and how to analyze our data, right? So talking about our data, how to analyze it. We'll display it, then we'll talk about some numerical summaries, and start asking some questions about the data. So first up, we'll talk about categorical variables. Again, we'll split our variables, kind of split between categorical and quantitative, and depending on what type of variables they are, that will dictate what we want to do with the information. So this first section is all about categorical variables, categorical data. And so we'll talk about how to show. This time around, we'll talk about how to show the data in a chart, in a graph, in a display. We'll talk about some things that you want to avoid in terms of when you start to make your displays this time around. And then tomorrow night, we'll talk about two-way tables and possibly trying to find relationships between a couple of categorical variables. And then we'll talk a little bit about how we want to sort of organize our statistical problems as we go through and try to solve them. We'll talk about that more tomorrow night. Okay, so we know that categorical variables are variables that place individuals in categories. The values of the categorical variable are labels for the different categories, and the distribution of a categorical variable lists the count or percent of individuals who fall into each category. Count or percent of individuals. And so here's an example of a categorical variable broken down. This is an example on page 8. Page 8 talks about Arbitron, which is a radio rating service. They gathered 13,838 radio stations and put them into categories based on their programming. And this is the data that they collected, right? And so we have our variable. Our variable is our format, right? Our individuals are the radio stations, right? Our variable is format, and format's definitely categorical. Genre, I guess, would be another way to name it. And then all of our different values, what type of radio station is it? From there, we've got two options. We can list the values of the variable, or how often our variable takes these values, either in terms of counts or percents. And so there's your difference between a frequency table or what's called a relative frequency table, right? A frequency table just gives us counts. This is how frequently we came across, or they came across, an adult contemporary radio station. They found 1,556 of those, which is easy enough to list and maybe easy enough to look at, right? So a frequency table just gives us the count. So I know that there's 1,556 adult contemporary radio stations out there out of the 13,838, okay? And if anyone has any kind of number sense, then you can kind of get a feel for if that's a lot or not in comparison to the whole. But not everybody has great number sense, and sometimes it's even difficult to get down into the exact allocation of adult contemporary radio stations. So what we can do is create this relative frequency table. And we throw the word relative in there because now we're going to take each value, now we're going to take each genre, so each value of your variable, and report it as an amount relative to the total. In other words, percent, right? That's what a percent is. It tells you how much relative to the total something is, right? So we do that so that we know that the adult contemporary radio stations make up 11.2% of the radio stations that they took a look at, okay? Which, looking at 1,556 out of 13,838, maybe we could get to 11.2% or somewhere right around 10%. But if we just go ahead and do that conversion for people, then it becomes easier to read too. So the difference between a frequency table and a relative frequency table: frequency table always does counts. Relative frequency table always shows percentages. And I think just a little bit easier to compare to the rest of the group. So, so anyway, those are a couple of tables that we'll use for categorical variables. Now, like I said before, you want to get into your individuals and you want to take a look at them one at a time, and really get down to the raw data. And there's some value in that as you're analyzing the data, but it's also very cumbersome. There's a lot of entries here, and it's not, very eye-pleasing, I guess. And so what we do is we can take these tables and convert them into something that's a little bit easier to look at, a little bit easier to compare things. And we can do that in two different ways. We can create a bar graph, or we can create a pie chart. And so what I'll show here is, again, from our radio stations, from our frequency table, we can create this bar graph, okay? My guess is you've created bar graphs before, and they're not that difficult. Now, you can create a bar graph for frequency tables or for relative frequency tables, either one. I mean, obviously, we can turn this vertical axis into a percentage, and it becomes a display of a relative frequency table. But anyway, you can get a sense of comparing each category to each other, where if we back up to the raw data, yeah, you see the numbers, but you don't know maybe exactly how much more one is than the other. It's just an easier comparison to make here with these bars, right? And so we can take a look and see that news talk radio stations, there are a whole lot more out there than rock stations or contemporary hit stations, which might be kind of surprising. Anyway, so that's your bar graph. You want to make sure that you label everything well. You want to label your vertical axis really well. Make sure that you label your vertical axis with all of your different values, and always give your bar graph a good title, right? We always want to make sure we're labeling all of our stuff. Believe it or not, there are enough points lost on the AP exam because people don't label their graphs. So do make sure you're labeling your graphs. So here's your bar graph pie chart you guys have seen before. Really, really nice. Pie charts are really, really nice to look at. A couple of downfalls here for these guys for pie charts. One, we don't really discuss them a whole lot, and I'll go back here. That always happens. I don't know how to keep that from happening. But anyway, they're hard to make. By hand, they're really hard to make because you have to make sure that the pie pieces are divvied up according to their percentages, right? You got to make sure that they're accurate. Now, computer software packages can do this pretty easily for you, but they're a little bit difficult to make by hand. The other thing is you have to account for all individuals. Okay, in other words, you got to have all categories in here, right? You have to account for all your individuals. So when we go through and list all the radio stations, now there may be more than, how many are here? 1, 2, 3, 4, 5, 6, 7, 8, 9 different values to our variable, but there may be more than that out there. And so typically what will happen in a situation with a categorical variable is we'll list out the main categories, and if there's some, a few and some other different values there, then we'll just lump them all together into an other category. So you kind of have to have an other category just so you can account for all possible individuals, okay? So do make sure that you're aware of that, okay? So, pie charts are nice. They are. People use them all the time. They're not really much of what we talk about in statistics, and I'm not going to have you make any pie charts, not by any means. And the AP exam won't either. But they do get used a lot. And so sometimes even more than they should. And so this Dilbert cartoon, which I think is always kind of funny, as Dilbert says, I didn't have anything useful to say, so I made this pie chart. And so the guys in the meeting are saying, ooh, it must be true because it's pi. And these guys are just all about the pie chart, and there's nothing in there. So Dilber says that worked too well. I pledge my life and my fortune to the pie. So again, pie charts get used a lot because they're so easy to read. They're just difficult to make, and you got to make sure that you're accounting for all the individuals. Okay, so that's the downfall with pie charts. Bar graphs, you want to be really careful with also. We compare different quantities by comparing the heights of the bars. We want to make sure that our eyes are responding to the heights of the bars only. Now what happens is, interestingly enough, is that our eyes react to area a lot. So if you do not keep your bars equally wide, then our eyes start to focus on and start to react to the width and the height, and we don't want that, right? I'll show you an example in just a second. So just make sure your bars are equally wide when you make them. Again, software packages can make them for you pretty easily. We'll do a few by hand, just so you have some practice making them, but they're not that tough. Just make sure they're, to the best of your ability, that they're equally wide, your bars are. And so a couple of things that happen a lot that we want to make sure that we avoid. One is putting pictures in place of bars. It can be very misleading, and I'll show you a couple of examples. Also, and I'll put this in here too, and I'll write it up here, you want to, at least for your bar graphs, start the vertical axis at 0. Okay, and I'll show you why you want to do that in just a second. But always start your vertical axis at 0. Otherwise, what you end up doing is chopping off parts of the bars and really magnifying the difference in the heights of the bars, and sometimes that can be misleading. And again, I'll show you an example of that in just a second. So here's an instance of a bad bar graph, right? So DirecTV is trying to put out this ad, and there's a couple of different problems here. So how many can you point out? Take a look at that. What issues do you see? Okay, jot a few ideas down. Maybe we'll put this up in class and talk about it together before we get started on homework, okay? But there's some issues here. There also, I did want to show this to you, and this is an example in the book. Let's see, of not starting the vertical axis at 0. And so this is from your example in your book, and hopefully you've seen this already because you're reading the book. On page 12, talking about different types of computers and the percentage that are owned, the percentage of the computers that are owned by computer owners. And so the difference in these two guys right here, this is what I'm talking about with magnifying the difference between the tops of your bars. Here your vertical axis starts at 0, and so you can see none, PC, and Macintosh. But if you start that vertical axis at 10, so you're really, really magnifying. So this is something that Apple might want to put out in an advertisement, right? So they can really emphasize the difference in the tops of the bar graphs here. So, and I can't remember what the setting was. I think this is maybe a college campus or something like that. But anyway, so just start your vertical axis at 0 so you're not over-representing any differences in the tops of the bar graphs, okay? Now, this all seems pretty elementary, right? And pretty straightforward. You know, why in the world do we even need to discuss this? Because there's no way anyone would ever go through this and make these graphs like this. Well, it does happen. Let's see. I'll show you one particular instance. This is from the Rachel Maddow show. She's on a news station and a political reporter for a news station. Right? And so check this out. Okay, so, even news stations sometimes screw up and make bad bar graphs. And so you just want to be careful about how you're making them. Right? Make sure your bar is the same width. Start your vertical axis at 0. And don't use any pictures, because pictures can be very misleading too. Because it's too hard to control the area. And again, our eyes always react to area. So be careful about that. There are some couple of examples of where pictures are used in the examples in the book that you want to take a look at as well. So, all right, so we'll stop there. You'll have an opportunity to make a couple of graphs, create some relative tables and some frequency tables and relative frequency tables. And then starting tomorrow night, we'll talk about distributions, marginal and conditional, and those can be a little bit weird, and we'll talk through those and make those make as much sense as we can. Okay? Enjoy your night, and see you guys tomorrow. And the homework that goes with this should be in your text. So feel free to look at that, or you can wait until class tomorrow.